All right, good morning. Happy Saturday. What is up? VP Tech Ops. Nice to see you today, my friend. What is this? I don't need this. Cancel. I think OBS still has some stuff. Is this broken? No, this is good. Okay. Let me grab the other chats. I totally did not set up any of the morning. Oh, that's not going to work, is it? Here. What's up, C. Grover? Nice to see you, my friend. Good morning and happy Saturday. I got some coffee here as well. Let's see, I want to go to... Oh, actually, we can just link from... Have the... Open the chats so we can see them. Alright, yes, welcome, good morning. Thanks to anyone who is watching. If you are new and don't know, or catching the video and don't know, my name is Tim. I go by Foamy Guy on GitHub and Discord. What's up, Johnny? Nice to see you, my friend, over in the Discord chat. And I usually stream around this time each week, 10 a.m. Central Time on Saturdays, working on stuff related to CircuitPython. If you don't know what CircuitPython is, you can learn more about it at the main website here, circuitpython.org. It is a programming language, an implementation of Python that is designed to run on tiny computers called microcontrollers. And it is primarily sort of aimed at education and makers to be able to teach people about electronics, teach people about programming, and to be able to make fun projects such as this one is one of my favorites with these little solenoids on a, not a piano, what is that, xylophone type toy? Not sure if that's the right name for sure or not, but in any case, there's a CircuitPython device here, there's a solenoid controller board, and there is some Python code, I believe, on this project that makes, that kind of brings it all together, all the hardware, and makes it work. And that is what CircuitPython is all about. So shout out to Liz for this, for the code on this and the project. Maybe with Noe as well for some of the design parts. I'm not sure, but possibly. So if you want to learn more, circuitpython.org is the way to do it, the place to do it. CircuitPython is an open source project. It is primarily funded by Adafruit. They pay a team of folks to work on CircuitPython, a small team, including myself. If you would like to help support them in CircuitPython, as well as some other open source development that they, sponsor, essentially, pay people to work on. CircuitPython is not the only open source software that they facilitate by paying developers, but it is the one that I work on most frequently. And if you want to help support CircuitPython and the rest of the open source work that they do, you can do so very easily. Just purchase hardware from them at their website, adafruit.com. And if you don't want to purchase hardware but still want to support, just come join us on Discord, say hi, interact with the community, build stuff, tell us about what you're working on. That kind of stuff is also very much appreciated. You can get yourself microcontrollers that run CircuitPython. You can get yourself little bits and bobs to connect to your microcontroller, such as the crazy solenoid setup here. You could buy the solenoids, I imagine, although I'm not sure on those. Definitely the little driver board and the main board and the wires, stemma connectors, get everything wired up. So all that stuff is over on Adafruit.com. Thanks to everyone who makes it possible by buying stuff from them to help them keep the whole thing rolling. I am diving in today back to the Zephyr world. So for anyone who happened to catch last week's stream, I got Zephyr going on the I don't know exactly precisely where we ended up last week, but I think at the very least, I believe I had it running on these things, right? I think so. Maybe after the stream, I got it working on those. We were working on the Feather, RP2040. We tried the Feather Sense. For a while, I was using Picos. I had Picos connected to this stuff, perhaps even before the Feather, I think. So that is the stuff we worked on last week, was kind of testing out Zephyr. It was my first time loading it up and just trying it on different devices. And dang, I will say I have come a long way in a week. So I did end up getting it to work on the Feather RP2040. I tested out both of those at the same time on there. And then since then, I've also gone and added a few more of the core modules. So pull up the PRs maybe. Easiest place to see that. The last two are Message Pack and AES-IO. And then the AES-IO one, there's actually some other changes as well that we'll dive into maybe a little later, that's to do with the testing in the native sim and stuff. So I have figured out how to enable these core modules, and I'm kind of like just sort of going through the list, finding ones that catch my eye that are currently not enabled, and trying to enable them, figure out what all it takes, if it's just a matter of flipping the thing to true, although this is not the place to flip it to true. I did figure that out. And so that is basically what I'm going to do today. I do also have in the build that is on my device right now, I do have a Feather RP2040, and it is running the Zephyr one, I think. Zephyr port RP2340, and actually the very last thing, the most recent thing that I have done, which is not pushed to a PR, it's not pushed, well, I don't know, I don't remember if I pushed it or not, but in any case, it's not like in anything official just yet. If it's pushed anywhere, it's just in a branch on mine, is bus device. So inside the core, there is an implementation of Adafruit bus device, which I believe started as a Python module, right? Adafruit bus device, it was a Python library, and there's now a core implementation of it. So most of the time on most regular ports, you would end up using the core implementation instead of the Python one. And it will be a little bit faster because it's not going through the Python layer. So that was not enabled yet, but I did actually tinker a little bit yesterday and enable that in a build, and I believe it is working, or it was yesterday at the very least. Yeah, okay, so I have a max, I've been working on the driver for this as well, so I have a max, what is it, through 40, max 44009, I think it is. How well it will. It's a little bit. But that's the new lux sensor. It's actually a very simple lux sensor. It does only lux, no proximity, nothing fancy. It does have interrupt, and it can set thresholds, but that's basically as fancy as it gets. So I have that connected. I have the driver that I've been working on, and this is essentially testing that Adafruit bus device in the core, where I enabled it here in the Zephyr port, is actually working, because the driver, we kind of follow the chain all the way down. The driver here is going to be importing Adafruit bus device, and I made sure that my Python implementation here, I changed the name of it to not Adafruit bus device. So when the core implementation is not there, the import fails, and then because I have it enabled here, the import succeeds, and theoretically, because the sensor is actually like working and returning data and stuff, theoretically the implementation is actually working successfully as well. Although I will say this is a very simple sensor. It is not doing very much over the I2C bus, so we would probably want to test it on something more rigorous than this before we like really call it actually working. But that's really my intention today, is to go through and find a few more of these that we can enable and just test it out, see if it works, try it. Yeah, see where we get. So as you could possibly tell by what I have the Featherwing loaded up with, I'm thinking NeoPixels would be a fun next step. I mean, NeoPixels are usually pretty high on the list of like what folks want to do with Adafruit hardware, Adafruit microcontrollers and stuff. So I think it'd be cool to get that going. It is actually technically possible, I think, because this is another one where in the core there is this implementation of Adafruit Pixel Buff right here. And so this is actually, again, it's like a C implementation of a Python library. There's also a Python Adafruit Pixel Buff, and I believe you could totally just use that Python library already, most likely, to control NeoPixels on the Zephyr port. But what I would like to do is enable the core one here and see if we get it working that way. That is where we'll start. And the way that we do that is actually inside of ports, Zephyr CP, and then we need to go to CP tools, build CircuitPython, and then here is a big list of default modules. These are the modules that are enabled. There you can see bus device is the last one I added, and then AES and message pack were the two before that. Those are merged in now. Adafruit Pixel Buff. Let's just put that and see if we get a build. These things don't remember very well here. So while that's running right now, we can go and do... This is something I noticed, is some of my REPLs have this like gap in it. And I can't tell if this is coming from my computer or the device. And I've seen it with both the Zephyr port and the non-Zephyr port. I've seen it on different devices, so that's what's making me think maybe it's my computer. In any case... Oh, that succeeded. That succeed. Oh, we have the Python one. Indeed, we have the Python one. Let's get rid of that. And let's reset. Okay, there we go. Now we have no module pixel buff. Pixel map is another one. That one's, I don't know if there's, I'm not sure if there's Python implementation of that one. Yeah, actually, I think there is. That one got a different name, though, so it's a bit different, but... At a time here. Alright, guess we got to build. Move this over so we're not covering up the camera, maybe. Of course, I can't, really? Zephyr, and then it's in this. That. Our bootloader drive. What we'll do is go to this view, right? Oh, it doesn't work. anything right now. Okay, hold on. Huh. Usually there's like Windows key arrow to like make a thing occupy half the screen. And then you can also choose another thing for the other half of the screen, and that is just not working. Which is unfortunate because it's actually a really convenient thing because they get like sort of linked together, and whenever you show one, it shows the other one too. That is a shame. Oh well. Okay, so the import works. So can we get the NeoPixels on the, like, that are actually connected to turn on and do stuff? For that, I'm just gonna go, we're gonna go to the Featherwing NeoPixel Featherwing. So what's connected? I don't remember what pin. It's like 9 or 10, or I think you can change it honestly, but I think it's on the default probably. Is their code, but there's not. But we could really hear. I just did it's on. You can connect it to whatever, like you can connect it to whatever you want, but by default it's on. Right. Has different names for different devices. It's the fourth one up from the, like what I'm going to call the bottom on the short side of the pin. So right, Feather has a long side and a short side. It's the fourth one up from the bottom on the short side. We actually need to see a real Feather. And I could look at it, I guess. Short side's here, fourth one up, 1, 2, 3, 4, pin 6 it looks like. Which I guess is what the guide said actually. Also cannot click. Oh, okay. So we would basically just need NeoPixel code with 16 pixels on pin 6. The 8 was usable. Let's see, import NeoPixel. I have NeoPixel? Yeah. And then NeoPixel in here uses Adafruit Pixel Buff, so that's how that ties in. So import NeoPixel, pixels equals NeoPixel. This takes the pin. We don't get to know code. This takes the pin, the number, and then optionals, board. Also, what is up, NIST? Nice to see you, my friend. Context though. Board dot D6, and then the number is it's 8x4, so it's 32. We'll do. I kind of like auto write true unless I'm doing any super fancy animations or anything. For pixel everything. Hopefully the rest should just be fine. Actually, you know what we want is brightness 0.1. We do not need to be going full brightness on those things. Stop fill. Let's go pink. And let's, I don't know if we need a while true. We might be able to get away without one. But I'm going to do a while true so that it holds the pink. module named NeoPixel Write. Line 20. Is that another core module? Did not know there was another part to that. Is that in here? It is. Okay, can we enable it? Okay, so one thing we do need to look at in order to enable it, I think if it has code in the port, then I don't think it will just work. If we go to ports, Raspberry Pi, Common HAL, yeah, see, so this has NeoPixel Write. What does the Python one use? Python one has no imports except for typing. How does that work? Post brightness buffer? Huh. Do not follow. How does this actually output anything? It doesn't. This doesn't output anything because it has no pin. So this must not handle. Does it work if we install this? Oh no. Because that's separate. It's from NeoPixel. Okay. Okay. So, yeah, we cannot do this so easily. We would need a Zephyr implementation of NeoPixel Write. We can take a stab at it though, and by we I mean Claude and me and everyone watching. So actually, one second. Huh? Yeah, there may be way more complicated things that are over my head that make this impossible. But it's worth just trying to ask if it will implement it and see what happens. Because we could point it to the Atmel implementation here. We can point it to the Raspberry Pi implementation. So this is like assembly sort of stuff going on. Interesting. What do the other ports look like? Espressif? What do we look there? Go for it. Okay. Yeah, let's try it. What's the worst that could happen? Where would we want to start? I think we should start in CircuitPython rather than starting in Zephyr. Yeah. Ports, Zephyr, dash, right? Dash CP, yeah. Dash CP common how is common underscore. Nope, dash. Implement the NeoPixel write into ports Zephyr. Actually, let's do this. Can you please implement the NeoPixel write module for CircuitPython Zephyr port into directory and reference other port implementations at port name common how NeoPixel write. For example, ports Raspberry Pi now you know if there are major roadblocks that would prevent this from being possible. See if it's like, because it's like, maybe that's, I don't know, you know. Maybe the way the pins work in Zephyr, I know Scott's talked about quite a bit, is different. There's lots of stuff that's different with that, so it may be the case that it can't because there's some underlying thing that's just not even hooked up or whatever, but maybe give it a shot here, like I said. Should it be common how? Probably. What did I put? Common cal. I totally did, yeah. It should be common how. They'll probably figure it out since I gave it the thing twice. Hopefully. Yeah, good catch though. I'm actually going to open this up as a separate instance of PyCharm here. I don't want to do the builds on the one, so like this is working in an instance of the CircuitPython repo that's on the Raspberry Pi. This is running on a Raspberry Pi. And I don't want to build from that instance, but I kind of do want it open in my editor so I can look at the code that it's doing and stuff. going to work today? Huh? Why is there no CircuitPython workspace? No, I swear I'm in a thing called CircuitPython workspace. CircuitPython workspace. Oh, it's not mounted. Not mounted. Why was it showing me anything? In the right folder? Yeah, I was in the right folder because I put PyMount here. Showing me cached stuff. Okay, hopefully I'll be able to keep this straight. CircuitPython 1 is on the Pi. CircuitPython 8 is on my local computer. Okay, let's see. It's trying to create the file. It hasn't written anything back to me yet, but I'll let it write the file. Eventually it'll give like an English overview of what it thinks, although the fact that it's writing the files makes it seem like we don't really need to do the native build for now. But I think it read the agents file, right? There's an agents file in here. I saw it reading that earlier. Right as, let's see, it's in ports, Zephyr CP agents, and it this has a bunch of stuff about building and testing. Like here, make tests, it was going to try to do the tests. But I don't want it to do that inside the Raspberry Pi, because it creates a bunch of big files and stuff that I don't really want on there. I have relatively little storage. I need to clean it off and start again on the Pi. Okay, let's just say don't worry about building or testing for now. I'll do that on a separate device. But it looks like it made the change. And it should, yeah, it should, I was going to say, it should give me like the summary or whatever. Understood, here's the summary. So NeoPixel write init, new, bitbang, WS812 using GPIO port, set bits raw, clear bits raw, acycle 32, IRQ lock, prevent preemption, executed from this, targeting this and this, ports. So it enabled it in that file to be able to actually add the module. So the module is enabled. It only needs a digital pin. The build script already globs this. Potential roadblocks, timing margin on slow indirect GPIO path. So Zephyr's, yeah, here's the kind of thing I was thinking that could be a showstopper here. So this goes through a driver function pointer on Cortex M cores. That's usually fine. Okay, so I think this is what, is this what we have? Yeah, I think this is what we have basically on a RP2040. It's where this is heavy. You might not hit that. If that happens, the fix is register access. Okay, there's maybe a thing that does this. Native sim can't test. It's funny that it knew this, but it was going to run the test anyway. Well, it didn't know this, but it wrote the text. Doesn't stop other cores. Zephyr currently talks single core, so fine today, but worth noting. Arbitrary pins. Okay, so this I think gets into what Scott's mentioned a few times and will eventually be a thing to try to tackle, which is the way Zephyr works. As I understand it, by default, the pins are more or less kind of static. Like you kind of define them at build time, I think. In CircuitPython land, that's not really how we do it, right? You can create a pin in CodePy. You can create a pin as a digital in-out, or if it's an analog pin, you could create it as analog in-out. If it supports I2C, you could use it for bus I/O. You can kind of like create an object to use it for whatever you want at runtime rather than at compile time, which I think is how Zephyr works. And it sounds like maybe, to me, what this is sounding like is these modules exist in Zephyr, but maybe more take that approach of you need to build with the pin already fixed into that behavior, basically, which is not necessarily what we want. Should be testable on a real board. Okay, cool. So the changes were in Common HAL for Zephyr. It's down here. I'm in the wrong one. Already failed that test. I mean, did I? I didn't make it all the way there. That's like a half fail. I'll give myself half credit on that one. I didn't make it all the way there. The NeoPixel right, we can copy that over to here. And I needed to be here anyway, right, to paste it. So maybe that's not even a half fail. Maybe we just give ourselves that one. I'm just going to cancel this for now. Zephyr bus device. Should I probably make a new... I should make a new one. Let's check out main. Let's update main. Committer stash. What are the changes? All right, so I have this problem. It's annoying because I literally just started CircuitPython 8 to get away from having a boatload of things that Git thinks that I've changed when I haven't. And now I have a boatload of things that Git thinks that I've changed when I haven't. So CircuitPython 9 folder might be getting started here pretty soon. I'm not entirely sure how to get these back to whatever they need to be so that I did not change them, because I did not really intend to. And I certainly don't want to commit them. We can just revert this, honestly. We don't need to commit or... We don't need to commit... Well, but we're going to have the same problem here? Are we going to have the same problem here? Yes. Okay, what if we try update this way? I don't tend to like doing it this way as much because it takes longer sometimes. But it does this shelve and then unshelve thing so that you get to keep your changes. But in addition to taking longer, it also gives you this progress thing that's not actually really a progress thing, which makes it impossible to tell how much longer it's going to take, which is a neat touch. These disappeared, which is interesting. Another change somewhere. Oh yeah, we needed that for bus device because of something to do with the name. Honestly, I guess I should have committed. Really, I kind of just screwed this all over because now I have unrelated changes all mixed in. This branch in the Adafruit bus device one, when I make that one, kind of are going to be intertwined, sort of. Zephyr, NeoPixel, right. Okay, and then to get that autogen back, I can just build again, as long as the rest of my changes are here, right? So let's double check. Zephyr CP common HAL, NeoPixel, right? Yeah. Oh, but it's not added. Need to add it? No, I don't need to add it to make the build. I can just make this build, that will get autogen back, and then we should be basically right back where we were. But now I'm in a new branch, so I'm less entangled with the other branch that I was on, even though I am still entangled. Copy recursively at file system to restore quickly. But I don't know where to copy from. I mean, I guess I could copy from, I could make a fresh clone and then copy from that. But if I'm going to make a fresh clone, in my mind, I might as well just move into the fresh clone. Is how I ended up with CircuitPython 4, 5, 6, 7, and now 8, or however many I have in there. I'm not sure exactly. You would think 8 would make sense, but skip some, I'm not sure. Okay, so now this is built again. And in fact, we want this to be rebuilt because this now has NeoPixel, right? And this succeeded, so that's good. Okay, let's try it. Go to bootloader there. Copy this. Still no NeoPixel, right, though. I probably should have done make clean. Also, let's make sure that it looks like it's enabled. Maybe with the shelving and maybe my checkouts, maybe something got messed up. Where's build? That's in CP tools. Still not. I'm like, I know where stuff is at, but I'm still not used to like actually pulling it up. Yeah, see here we need NeoPixel, right? Oh, that's because I didn't copy over that file. I only copied over. Yeah. I mean, it told me about this. I just didn't do it. I didn't copy that over. My bad. Okay, so NeoPixel right, we want that here. Then we make a build. I did do a clean, so that'll be good. Let's look at what it did while it's working here in the NeoPixel right. We'll ask it maybe if these, I assume these numbers came from one of the other ports. Hopefully. But it didn't just like choose more or less arbitrarily. I mean, it's not super in depth. Like, I will be honest, I don't understand all of it, but there's not that much code to it, so it theoretically is like not that complex. And just chunking out bytes over this pin using a redefined sort of signaling system. Yeah, it'll be interesting to see if it is fast enough or whatever. The other thing I will say, even if this works, there is a decent chance it's not going to be the way that Scott wants to do it, I'm guessing. On account of the pin stuff, and also there may just be like a better, even if it's not actually handling the pin stuff thing, there may be another better way that I'm just unaware of in Zephyr world. But it would be cool if it works. Get the ball rolling at the very least, hopefully. Does not crash, but it also did not turn the pixels on. But I am gonna say that I am gonna say that the pin 6 feels wrong to me. I don't know why, but pin 6 doesn't feel right to me. But maybe it is. It's not. As you can not quite clearly, but maybe possibly see a little bit, the default one has been cut, and there's a solder blob a couple over. So somebody, not trying to point any fingers here, but somebody has changed it and then forgotten what it was set to. So that would be not labeled on this. 10. I was 10. Okay. I was thinking 9 or 10, honestly. In my head, it was 9 or 10. Maybe this one's 9 and this one's 10. That could be. I don't know. I think I, at one time, used this with something else that was on pin 6, so I changed it. I shouldn't do this with it plugged in. Bad form. See, I didn't even hit the holes, so. There we go. We need to change that to pin 10. With a little bit of luck, it might actually work. I mean, it's not like crashing or hard faulting or doing anything crazy with the NeoPixel writes, and theoretically it is waggling pin 6 in a way that would make NeoPixels go. They're just not connected to that pin. All right, I can't. Boy, that Windows key thing, that is brutal. I hope that gets fixed after I reboot. Oh, as you can tell, they're on. They're on very bright, and they are on all the way white, though. I would say it is not quite working because the brightness failed all the way. And they're on white instead of pink. They are on. And we cannot turn them off. Okay. Yep. Cannot turn them off. Alright. We'll carefully plug this. I should change the, well, I did change the code actually. It's on, but if they're not writing correctly, okay, yeah, I should have changed the code even further, perhaps. Still turn on. I think we need to not them at all. Should stay on with that, but if I unplug again, not turn back on. Yeah. Raspberry Pi has it for Feather on pin 16. The onboard NeoPixel? Be the onboard NeoPixel. SDK source boards. What is pin 16? We don't have a pin labeled 16. Red and blue equals, also there's a power pin. For them to save power? Uh, okay. Yeah, the built-in NeoPixel is on 16, but I'm using the externally connected strip. We could try the built-in one, see if it's any better at controlling that one. What's up, Tithe? Says on Twitch, hey Tim, yeah, pin naming and numbering and multiple labeling system just makes no. Yeah. Oh, there should be labeled this way in CircuitPython. Should be able to access it that way, I'm pretty sure. So auto rate true brightness 1 will do back to pink again. I don't think it's saved. Not saved. Oh, it did. Module has no. It doesn't have. Really? Maybe not in the Zephyr build. Hmm. Yeah, that's just not exposed. I don't know how to get the pin. These onboard NeoPixels, you can improve basics RGB hue. Yeah. Yeah, I don't know how the pins are defined. Can you get it via microcontroller pin? Maybe. Okay. Yes, we can access it that way, but it does still turn on bright white only. Okay, maybe we go back to this one. I was gonna ask it how the pins are defined, but if we can use microcontroller, that's fine as a workaround for now. We can figure out the pins later. Oops. We had a. Oh, what? Why did it turn back on? Just not leave it off long enough? Weird. Okay, interesting. You gotta leave it off for longer. Huh. I tried this, and it makes the NeoPixels turn on full brightness and always white instead of the color I set. Even setting black, it's them on full white. scratchpad file that's not this one. We might give it the NeoPixel library. I don't know if that'll help it. I mean, the good news about the NeoPixel library is it's one of the most widely used ones. So of all the ones that these things will have probably consumed during training, that is probably one of them. LED. .LED, maybe you were saying .LED for the pin? Yeah, so those are the they're not NeoPixels. They're just like the little red LED. Like usually it's on D13 on Arduinos and stuff. It's the little red one that's by, I think it's up here on this device. You know what's interesting is the chart. There's no charge blinker. Get rid of the charge blinker, or it only blinks when it's charging now or something? It was Cutie Pie on the power thing. Oh, is there like an extra pin that you have to, yeah, like an extra digital pin that's like an on-off switch sort of thing built in internally to the board or something? I've seen boards with peripherals that are like that. This is a harder one. Yeah. My guess is that it's like not fast enough / we can't just do it with GPIO raw or whatever. We need to probably do a real way. Yeah, okay. Gonna find two copies of the repo if it looks here. I don't really want it to do, but I really want it to just stop either, so hopefully it will figure out that it's just 2 copies of the repo and will not like get confused trying to read both. I find it interesting that effort medium just disappeared from down here. Dean Miller wrote assembly for SAMD21 for Cricket that uses a lot of NOPs. Yeah, we saw in the Atmel port there was some assembly in there. I don't know if it's the same thing that you're mentioning, but yeah, totally it was. If we go here, ports, Atmel SAMD, Common HAL, NeoPixel right. So it has this whole send buffer core action. Looks annoying too because it has different assembly for lots of these different boards. Like to follow the logic in this is kind of crazy. All right, so it's got some ideas at the very least. I'm just gonna let it do writes for now. Okay. So symptoms, all bits latch 1. Full brightness means the high pulse is longer than this. Going through this, it has function call. We can't get low. Let me look at this. Fixes direct register access. Going through that plus this adds too much overhead. Rewrite. DWT does that. Sock specific fast GPIO. Interf. Fallback timing. Okay, so it actually has now changed, it looks like, these timing matching known good ones, so maybe it didn't pull those from others before. Wrote some stuff. Let me also... What? What? I don't recall ever seeing it do that before. And this is Claude code, by the way. This is not OpenClaw or any of the other ones. This is just Claude code. Interesting. It says Control O to expand, but I definitely pressed Control O, and it definitely is not expanded. So that's hopeful. I'm kind of curious about what it wrote, but I cannot just go catting files in the Claude directory on the stream. Don't need to be leaking any tokens. All right, so it made some changes. Timing source now does this thing. Read these things, like, and again, like a lot of this, I'm honestly, this is a lot over my head, but I know how to test it. So like, if it can write some code and I can test it, we might be able to get there together. GPIO writes directly to this, resolving ports by comparing that. So we're not making a solution that's specific to NRF though, are we? I actually don't have the I don't have the NRF one here right now. Somewhere else. It's upstairs. I'm using a Feather RP2040 test. Let's see what we end up with. Yeah, I'm super curious about the reasoning thing or whatever. It says usually thinking medium or whatever down here. It's just gone now. In a bit longer. All right, while that's running, I'm gonna go to the restroom real fast. I'll be right back. Still going. Let's try for a little bit longer on NeoPixel. If we don't end up getting NeoPixel going after not too much longer, I think I will step back and aim for a module or two that doesn't have hardware interaction. Because I think this is a lot harder because it's actually trying to connect to hardware, in this case NeoPixels, and it's trying to connect to them using this hyper-specific protocol that they define, and it has to hit these tight timings. And it is effectively all over my head. But there are some modules we could do which I think are easier, quote-unquote, easier targets for this, like you take another stroll through that autogen list. I want to say hashlib, zlib. Those are the two I had in mind, hashlib and zlib. What is this? We're in the wrong port, I think. Yeah, zlib for zip stuff, gzip, unzipping, indoor zipping. Not sure if it implements both. And then hashlib also, I think, is not enabled. Hashlib is like sort of crypto-y. I'm always into doing sort of crypto-y stuff, so that one sounds fun to try. I mean, it looks like it's going to try to chunk through it. We're getting up there on context. I am using a subscription one, not the API direct, so we don't have the big mega window. Fudge, yum. It is weird since Zephyr supports so many different devices. It does strike me as a little bit awkward that, like, on the other ports, there's like ports, Atmel, SAMD, Common HAL, NeoPixel write, and this contains the code that's necessary for Atmel SAMD to do this, right? And the NRF one is inside Nordic here, and it contains the stuff for Nordic stuff to do it, and the Raspberry Pi one, and so on. But in Zephyr, because they are up another level, kind of, somehow there would need to be a mechanism in here that differentiates RP2040 from NRF, from Atmel, if that's ever supported, so on and so forth. It looked to me like it's probably just doing it in this file, probably with some kind of if macros or whatever, but yeah, we kind of lose that layer of splitting apart the ports, essentially. So this RP2040 key changes, GPIO writes directly to the SIO block. 2 cycles per set, clear timing. Cortex M0 has no DWT, so use inline this thing. For this, bit loop restructured to delay both high and low per bit. Those things, since without a free running counter, we can't just wait for end of period of small fudge. There's our fudge right there. Nice, yum. Per iteration branch shift overhead to keep the total bit period near 1.2 microseconds. That's micro. Give it a try on the feather. If the bits are now correct, but a particular color channel looks shifted or slightly wrong, we can nudge those constants. If it's still full white, the SIO writes are being delayed somehow. We'll need to look further. All right, give it a try. And I think the only changes that it made was in the implementation here. I am curious, did it do... Yeah, totally. So it made this layer here, right? It has this resolve port where here's where it's checking which port we're on. It is weird that it's NRF P0, NRF P1. There's RP2 ones. So yeah, I imagine that Scott will have an opinion on how this sort of layer of like differentiating the NRF implementation from the RP2040 implementation. I imagine he'll have some thoughts on how and where that happens. That may not line up with the first try that this thing spit out, but we can definitely see if it runs, which is always fun. Yeah, and I don't really have enough context on that sort of top down. Like, I don't know how much that affects. I don't know how many different things are going to have different stuff per port like that. So I don't know. Yeah, I don't even have like the beginnings of a formulation of a thought on the right way or a good way to handle that. I shouldn't have done add right there. I mean, I guess it doesn't matter. We're on a branch for it, but ESP NeoPixel Seesaw board. So I did get Seesaw going the other day. So Seesaw we got because is that true? I'm not sure actually if this thing has a Seesaw anymore. I want to say that it does, but I'm not sure actually. But this one does for sure. This one uses a Seesaw for the D-pad and the buttons, and it was like the reset pin or something on the display. And this one we got going on Tuesday stream, I think, if I recall correctly. All right, did I paste this? Yeah, okay. We're in CircuitPython 8. That's the one I want to build in. We have all of this stuff. Should be able to make a build. I'll do clean again. I'm still not quite sure when we need clean and when we don't. I guess I could have tried it without, but it doesn't take that long to build. It's like longer than Raspberry Pi port, but not as long as ESP port on my computer at least. Oh, we have reached the end of the coffee. Yeah, so now it's just straight up setting low level stuff, it looks like. And I have no idea, does that sort of match what the Raspberry Pi port does, or is it totally, entirely, completely different? It's different. This one uses PIO. It might be worth asking the CloudBot here if it could use PIO on Raspberry Pi. I don't know about Zephyr PIO stuff, if that's possible or not. I would imagine so. And if it is, I would also imagine we probably want it to be done that way instead of whatever's going on in this one, right? This is just writing low-level registers or memory or something that I presume would make those pins toggle. Oh, didn't build. Errors in task group. It's definitely not clear to me, but I'm not used to reading the fails on Zephyr builds, and even to a lesser extent core builds. I mean, I'm getting better at core builds, but at understanding what's actually wrong based on what it's saying here, or to put it another way, about understanding where the parts of the traceback that are most important are at. How to read them to kind of like find most vital stuff. Assembler needs explicit 3 operand form of thumb1, subs this being parse thumb2 encoding. Yeah, okay. Try that build again. Right, let's try it without clean. See what happens. And we'll, because we'll know if it matters, because it will fail again the same way if didn't pick up the new thing or whatever, right? Oh, I had a coffee. All right, let's try clean. Although I think it's still probably, it just failed for a different reason now, because I think that said 32 last time, didn't it? No, it did not actually. It said 16, okay. All right, well, maybe after clean. I think we're farther. All right, so note to self, clean always. Gotta do the clean. I almost wish that make would just have clean automatically at the beginning for this port. You need it always. There's probably something you could change where you don't need it. It's definitely making it further. The IDE to catch up to all the new files? Nope. Still failed. Same thing. Well, looks like the same thing to me. All right, we'll try one more thing here. See if it has one more idea. But then I think I will admit defeat for now on modules that interact with hardware that have hyper-specific protocols that I don't understand. And try maybe hashlib and zlib, see if we can get those two working. One or the other, and or both. It's easy, we'll see. The other thing is with those two, like, I have a clear idea of how to write the tests for them too. Is like one of the other things about the Zephyr port, we have the native sim and we have the tests. Inside Zephyr CP tests, there's all these different files. Somehow main, oh, it is, okay, yes, is there. Okay, I was gonna say somehow the new one's not there though. And I imagine the idea is like we probably want to have one of these for every module, but I have no idea like how would it test stuff that has hardware? But actually the answer is this is doing it somehow. I don't really understand what is going on in here, but this totally is doing a digital input trace. UPIO emulated. Okay. So we would need, I don't know if the emulation thing can do whatever it would need to for NeoPixel. If so, then we would make the test this way. No, still. I don't want to necessarily wait for like too long either. So give it a minute, see if it has a quick idea, but it'll start getting crazy too once this is full, so be time to bail on this session, probably. I should have asked this before. I don't know if that will just completely throw it off the rails or what. I'm not sure if it will like respond to that either. I should have done this maybe. Probably should have done that. Oh, that's a queued message. Oh, okay. Still try it maybe? I'm not sure I did the, I'm not sure if I did that the right way. Made some changes though. Those gas attempts. Try the build again. Maybe it is doing PIO now. So it's unclear if it ever answered this really. I mean, it feels like maybe this is the answer, but it did not do that. All right, well, let's try this one. Still out of coffee. I guess it 2 is, yeah, I don't know. I feel like the BTW thing is, I don't really understand what it did or didn't do. This avoids the bit timing problem, fixes the build error because there's no inline assembly, and it matches what the native port does. Okay, for other protocols. I don't care about other protocols right now. Okay. Interesting. All right, let's see if it... Okay, this one did build. A little dicey, just running stuff that has random assembly changes in it. I don't remember what code I left in there. I think it's none, right? Yeah, it has no code currently. Let's do this one. Oh, interesting. Okay, it's on, but it's teal. It's not pink, it's teal. And it is quite bright. I don't think it respected the 0.1 brightness. We try changing it. Does it change? No, it's always on. Actually sure if it changed or not. I really wish that my arrow key thing would work. Okay, I don't think it changed. I don't think it actually changed. Because we can't turn it off either. Yeah, I think it's still not working. Whoa. Now that whole BTW thing is just gone. Okay. That's interesting. Oh, it is changing almost. It looks like... It's definitely different than it was the very, very first time. This is now like green, green. I set it to, actually. But then I turned it off. It's like behind? Oh, interesting. It got slightly yellower. I don't know. It's not just a color order problem. Because it's also not turning it off. When I turn it off, it goes to green. But it is changing now, which is good. Before, when it was on white, it was not even changing. We're already up to 150k. I'm kind of scared. I do kind of want to try the other modules, but I am curious about the PO approach. Since it's going so far sort of off the rails with assembly stuff, like, it could use PO and try to match the Raspberry Pi port. I think we have a better chance of it succeeding. And I think it's more likely to be how we would want it to work for the Raspberry Pi port, since that's how the non-Zephyr... When I say for the Raspberry Pi port, I mean within Zephyr. again, like as we approach the maximum here, it's gonna get wonky on us. We might already be past the threshold a bit. Okay. While that's going, let's start looking .org. Okay. This one doesn't have port-specific code, I don't think. It says, without knowing for sure, but I don't think so. Yeah, so like here, there's no hash lib. It's implemented only in shared module, I think. Shared bindings has the Python binding side, and then shared module has the implementation. So that one, I think we could just enable it, and it, fingers crossed, might just like work. I'm gonna give it like maybe one more minute here, and if it doesn't spit something out, then cancel it and just try hashlib instead. We will need code for it though, I guess. So we need to, yeah, it gets weird. We need to name, we need to make a hash object from this, and then we call update with bytes, and then we call digest, which will give us bytes. And we could convert it to hex if we wanted. That's kind of typically what's done, but it is optional. So we don't need show because I put, well, theoretically we don't need show because I put auto show false, and then green, in your example there, green is just from some other library, like LED animation library maybe, or the NeoPixel library. I'm not sure which one, maybe Rainbow IO. I don't know where they are, but somewhere there's color constants, essentially. But it should work the exact same as just doing the color like this, and then we don't need show, like theoretically at least, we wouldn't need show because of auto show being true. It's at least said, it's at least got to the point of saying it's going to do that. Oh, there's our compacting. And it does not look like it actually did anything with PO in this change. It's deleting a bunch of stuff. Oh, there it is. Okay. Looking through our 5-hour window there. Although I didn't think it's quite 5 hours. I was noticing the other day it doesn't really line up with 5 hours. So I wonder if it's done or... All right, this is the last try I'm going to give it on NeoPixel. With one exception being if it does finally finish and is like, I changed one last thing or whatever that I didn't get, then I'll try again after that. But assuming that it was actually done writing code, put this one here. All right, so yeah, I totally like compacted it way down to that. It is finished now, so I could copy it again to make sure we have the latest one if it did change anything else. Okay. And then either way, I'll try to do a hash lib after this. I do want some code that tests it. We could write that now. Got 256. Hashlib.new. 256. What else did it want? Data. Interesting, it does not say anything about data here. I'm just going to not give it data. And then only give it data with update, I guess. 256 update data bytes. I don't think it actually has a hex digest. I think we have to use bin to ASCII to do that on CircuitPython. All right, this built. Can't see the reset button because of the green light. All right, output's nothing, lights on green. Code is what? Leave the code on. So the code says off, and it's not turning off. And now it seems to no longer react either. Before we were getting like when I reran it, it would do something, it would change a little bit, but now it's just stuck green. Okay. All right, we gave it a valiant attempt. I think what I'll do is just, well, I could commit it locally, I guess. I don't know if it'll ever be useful, but hey, wait, why did this change? Oh, goodness gracious. I think it got confused entirely, and it put the Zephyr stuff in the it put the Zephyr stuff in the non-Zephyr Raspberry Pi port. So maybe if we would drop that one back over into Zephyr, but I you know, again, like I said, I gave it the tries. But that's good to know. Like, it actually just put it in the wrong file, it looked like. Could modulate the dot stars with Morse code if you had to. Yeah, there you go. I do have, that's the other one here, was dot stars. If it turned out that NeoPixels was easy and it just worked right away, then I was going to try dot stars too, but more complex than I was able to handle, turns out. All right, I'm going to go main, check out another new branch from main. Zephyr, hashlib. I'm just going to call it hashlib, but if this works easily, then I might do zlib as well. So here we would go no, wrong place. We would go CircuitPython build CircuitPython actually. We would go here. We would go hashlib. Wait, is that turned on somewhere? Wait, hold on. I think I've looked into this before. Okay. Hashlib is enabled, but only if network is enabled right now. But I don't want that. I want it to just always be enabled. I have no idea why this just completely changed everything. That's... So is it going to add it twice now? On the ones that have networking enabled? I'm not sure. Let's just turn it on and test it though. All right, we want B2A, really want B2A hex, but is that hexalify or is that... Okay, that's what I want. Hexalify. You called digest twice? Not sure. Oops. Did not build. Okay, I gotta run to the restroom again. Sorry, BRB. the take this back out as a build? Done a clean. Is it already there? Maybe it's already there. Well, no, because I looked at, did I not look in the autogen list? Oh, it is there. Well, was it there? Is it actually there, or is it there because I just made half of a build with it turned on? Guess that's what we'll find out if this one succeeds. If this one succeeds, though, then I'm not exactly sure why the last one failed. Got farther and it did turn it off. Okay, so it's not enabled in main, and my thing did enable it, but build failed. So the question is, does the build, have I just broken it with making a bunch of changes and Git checking out different branches and stuff? Maybe I'm not actually in line with main right now. Maybe something's still broken from NeoPixel stuff. Nope. So hashlib actually breaks it. Interesting. Why would hashlib break it? Especially if it's enabled for the networking one. And it does not. Okay. On there right now. It just didn't open. Didn't need this? I still actually don't get to know whether the clean is required or not, since we ended up having the same error earlier. Even with the changed code, it doesn't tell us that clean was or was not required. Oh. 7%? Getting up there, I thought, the last time I saw it, but I don't think it was at 90 anything percent. It was in the 70s, I thought, when we saw it last. I'd have to check the stream, though. That's kind of annoying that it just jumped. I do actually have the free credits or whatever. I don't know how to apply them, though. I'm not going to do it on stream. – 102 mentions. Oh, there were some fails near that one. Yeah. Probably just undefined embed TLS. I see. Okay, so in shared module, it's trying to use embed TLS something something, and that's not existing. Which makes me think even for the boards where it was enabled due to the due to the network being enabled, I kind of have to assume that it would not actually work. Somehow it needs to get embed TLS linked correctly in the Zephyr port, and I do not know how to do that. Claude might know, but I am at the limit. NeoPixel experiment ran us out. Wonder, you look at something. All right, let's try zlib. I don't have code to test, but we could run it, I guess. Wrong one. Most likely, I'm guessing the fix for hashlib is not going to be that hard. It's probably just figuring out how to tell it to use embed TLS. Oh, it just needs to be brought in into that build. Or where this one pulls from. I mean, allegedly here there is one. Maybe. Oh, zlib failed too. Dang. What does zlib use internally? It might, maybe it's also using it. Uses lib use zlib. Which might also have to get linked somehow, basically, or whatever. Presumably these would have failed for like more or less the same reason, maybe. Undefined references to all that stuff. Okay. The one's gone. So I just, for anyone who doesn't know, like Anthropic Claude, they gave away a $20 credit for overage or whatever. I think kind of as an olive branch offering because they disabled the ability to use third-party harnesses like OpenClaw and Open Code or something. There's a different coding one as well. There's also Pi coding agent that Scott was using. I used that one a bit as well. Okay, yeah. So I was gonna say I went and enabled it because they just gave away $20 in credits. I think kind of as a like we're turning this off, but you can use it through the API if you want. Here's $20 to try it on us and hopefully get hooked and then keep paying for the API tokens that way, I think. But I am currently a subscription only, but I will use the $20 if they're going to give it to me. Should have probably pulled the plug on the NeoPixel experiment earlier. That's right, the link fails because of this. Okay, what do we got? The link fails because hashlib via this pulls in embedded this, but Zephyr only builds that when it's kconfig, networking boards. Oh, it is back to the networking problem. Networking enables something else also. 2 ways to fix. Enable it globally in pjr.conf. Not sure if we'd want that. Poor board, add the same 4 lines to each board. Interesting. Where's that PJP? It's right here. I think we should. My thought is it should be enabled on all boards. Whether or not they have networking. And it is still possible to disable it per board on boards that don't have enough flash. So like Raspberry Pi Pico, just plain Pico, there's no networking here built in, right? There's no Wi-Fi. There's Ethernet, I guess, but like it's on the WizNet, whatever. It's like not on this board, right? But this does have hashlib. And no Wi-Fi here, right? So I think we would want Zephyr to match that. I think we would want hashlib enabled. So my read is we would put this stuff in the PJR file, which is top level. And then on a per board basis, we would disable it on ones where we don't want it. The right stuff? Okay, yeah. Which we would have to do, for instance, in the, what was it, Nordic 2007 something? 7002, I was backwards. In this one, I had to do a disabled modules, and I had to disable AES-IO because it didn't fit in the flash. And so I imagine we would have to do the same thing here with hashlib for this one. I'm not going to mess with it at this exact second, but I think that's the approach that makes the most sense in my head, off the top of my head. And I would love to see if this builds, and then I'll probably wrap it up after we find out whether it does. Probably that I test it as well. I'm going to try no clean. Like, we need to get away from clean every time if we can. How much did we use? 24 cents. Working with the build config files was the most frustrating part of the WASM port, getting flashbacks. Yeah, gotcha. Yeah, I don't have a good grasp on how all the build files interact, really. Alright, so we did still fail. Now the question is, are these old or? Now we have no There are errors about hashlib. I can see. Oh no, this says zlib. Oh no, I did not change the right thing in the right. I changed it. This is the problem with having this one on the Pi and this one local. I changed it on the Pi one, but then obviously I came back to local to build it. Oh no, but it's still a zlib thing. All right, we need to clean. It's weird that this did not have any embed TLS stuff before. Because I wonder, now I wonder, like, on the builds where that network thing was true, do those actually build? And if so, does hashlib work inside of them? Or would they have run into the same problem, which is that they don't actually have embed TLS linked? I think the networking stuff is like cutting edge. I don't think any of it is actually working at this point. Scott's working on I think Ethernet. Well, he's gonna work on Ethernet. I think he started Wi-Fi, but it's also not working. So yeah, I think the answer may just be that there possibly just are none really that actually have networking all the way. All right, this should be back to failing because it cannot import the thing. Nice. How close is this to CPython? So it did something. It works. It looked like it works at the very least. But what we don't get to know for sure is it's like, is this correct? Just by looking at it, I don't happen to know the hash of this. But I think this is close to CPython. ASCII is not defined. Yeah, totally. Sweet. Cool. Okay. We got one win at least. Hashlib enabled, and it's giving the correct hash for the string at the very least. Zlib is probably the same thing, honestly. Like in here, it probably needs something zlib, I'm guessing, to pull that in. If not, only here, maybe here and one other place too. I wouldn't be surprised if there's another place that would need it as well. On account of embed TLS possibly already being in the mix for networking, if there is any actual networking stuff going on, which I'm still a little unclear on. zlib definitely... Actually, zlib might be in the mix for networking as well, because lots of web servers return zlib responses. Well, I don't know about lots, but some do. In any case, we did get successfully hashlib enabled, and we got the right value back out of it, so that's cool. I will have to get the files cleaned up and get this one submitted as PR to enable. I would still like to look into zlib, but I'm not going to do it now. That is going to be it for the stream today. I will be back on Tuesday for the Tuesday morning deep dive on the 14th, 10 a.m. Central Time. Same time that I started today, just a couple days from now on Tuesday. That'll be over on the Adafruit channel. As far as I know, Scott's around for deep dive on Friday, so check that out then. And I should be back next weekend, 1 week from today on the 18th at 10 a.m. Central Time, also here on my channel. So thanks for watching. Hope you all have a great rest of your day and weekend. Yeah, I'll be back Tuesday. Should be back Saturday next week as well. So long, farewell. Thanks.